I think we're recording. We'll see what happens. Sometimes my computer glitches out and it doesn't record, so there's always that possibility. I hope that's not the case. Yeah, so 1A, number of fireplaces, we're trying to predict the property's value. No, 1B, is it positive, negative, neither? I would say positive, okay? And why is it positive? Okay, well, what does it mean to have a positive relationship? No, not positive really. All right, here, let me answer this, okay? So somewhere in your notes, you should have positive relationship means large values of x are associated with large values of y. Okay, so I posted the notes up here as well. Okay, so, and that's what we see in general. We're talking about overall trends. Okay, so if somebody says we have a house has lots of fireplaces, so positive relationship, large values of x are associated with large values of y. That's what we have. In general, homes with lots of fireplaces, if we had to create an overall trend, seems like more fireplaces, higher value. Okay, large x associated with large y. Lot of fireplaces, more, the property's worth more. Is that okay? All right. So we have a positive relationship there. Okay. It says in graph A, would you say the relationship is strong, weak, or moderate? Okay, I guess moderate is okay. I was going to say weak. I was going to say weak. All right. Right. What does it mean to have a weak relationship? Not the straight line. Okay. Okay. Let's see. Okay. So the weak relationship means there's lots of scatter. Okay. If the relationship is weak, we've got lots of scatter. Okay. You know, if somebody just told you the number of fireplaces, like if somebody says, oh, this house has 2 fireplaces in it, there's a lot of variation. It can be worth as low as 100,000 to 300,000 or 450,000. Okay, obviously this is not in California, probably some other state, but you know, if you have a place has 1 fireplace, it can be worth anywhere from 100,000 and 280,000, something like that. You've got a lot of scatter. So I would say it's weak. You know, if you want to say weak to moderate, that's fine. Okay, in graph B, what is the variable that is used to predict the total value? So now we're talking about graph B. Yeah, the number of square feet in the property, right? Okay, so square feet of property. Okay, and what kind of relationship? Negative, positive, strong, weak, or moderate? Yeah, so I would say, so this is positive. More, if a place has more square foot, it's going to be worth more. And I would say pretty strong relationship there, in that it seems that the number of square footage gives you a lot better idea of how much the property is going to be worth.
Can you go over that? Explain why.
Okay, so one way we can kind of get
You have to get a straight line, right?
Okay, so the straight line business is just whether or not correlation is the proper method for analysis. Okay, so if it is not a straight line, if you see a curve, correlation is not appropriate. Okay, that's the key. What we're talking about when we talk about positive and negative is, does large X go with large Y or does large X go with small y? That's going to decide whether it's positive or negative. And then strong or weak is is there lots of scatter or is there little scatter? Okay, and so here I would say just a medium amount of scatter. So I would say strong, maybe moderate to strong for the number of square foot. As far as the number of fireplaces, we see for each value we see lots of scatter. Okay, and you see the you don't see anything right here, in these gaps in between, is because you can't have a place with 2.5 fireplaces, okay? But in terms of square feet, you can have a place with 2,000 square feet. You can have a place with 2,003 square feet, 2,004, even 2,004 and a half square feet. That's allowed if you're going to get really precise in measuring how much area the property takes up. But in terms of the number of fireplaces, you can't have 2.5 or 3.5. So that's why you see the dots in kind of these columns here. But that's what we got going on.
So
Yes.
then in picking the red beef, it makes it strong because you don't have the barrel.
You have less scatter. You have less scatter. Okay. I mean, there is a good amount of scatter still. Okay. It's not. These aren't perfectly aligned in a straight line. In that there's no scatter, but there is some scatter. But there's a lot less scatter here than over here, I would say. Okay. So that's why. So positive is touching it. So basically, positive means it's going up in that direction. Okay. So anything that's up in this direction, the angle doesn't matter as long as it's going up. That's going to be positive. And if it's pointing down this way, it's going to be negative. Okay. If the dots are little scatter, means strong, and then lots of scatter, you got a weak relationship. Okay, let's look at G, H, I, and J. Okay, what is the approximate value of the property that has the highest value? Okay, so the one with the highest value is this dot. It's the same dot over here, and it looks to be about 450, 460,000, something around there. Okay, at 470, that's fine. Okay, so 460,000. Okay, yeah, so 450, 470. I would take anything between 450 and 470,000. Okay.
We can put like that.
Yeah. Okay. You just pick a number, okay? Because there's not a range associated, but just said approximately, right? I didn't say give me an exact value. Okay. Okay. What is the approximate value of the property with the most number of fireplaces? How many fireplaces does this property have? Okay. So, okay, it has 7 fireplaces, and how much is it worth? About 400, 390, I don't know, something. Okay, we're just eyeballing here, okay? Okay, so H has 7 fireplaces, and it's worth about 390,000. And if you have something at least in that ballpark, that's fine. Okay. And that again is just reading the graph. We see the place with the most number of fireplaces has 7 fireplaces, and it's worth about going across 380, 390, something around there. Okay. If you're off by if your number is different from mine, but I would say within plus or minus 20 or 30,000, that's fine. Okay. As long as no one's saying 450 or something like that. Okay, because that's not correct for that question. Okay, what is the approximate value of the property with the greatest number of square feet, and how many square feet is this property? Okay, so it's the one that's worth the most, so around 450. It should be, whatever your answer was to part G should be the same as your answer to part I, and you should say it has around 3,500 square feet, okay? So whatever, so you should say maybe around 460,000 with 3,500 square feet.
Or we can mention 450,000 to.
Yeah, okay, whatever you put for G should be your answer for I with 3,500 square feet. Okay, and then J, based on these graphs, which variable would you say does a better job of predicting the total value of a property? Square footage, right?
Can you explain that?
Okay, well, so if someone said, I want you to predict how much this house is worth, and they said, and you said, well, can you tell me something about it? And they said, well, I'll give you a piece of information. I'll either tell you how many fireplaces it has or how many square feet it has. Which would you rather have? If you'd rather have the number of square feet, right? Because you can do a better job predicting. Okay, so I'm hoping this problem went okay with everybody. Okay. All right. Yes. Okay, letter H. What's the approximate value of the property with the most number of fireplaces? Sure. What's your question? The most number of fireplaces. Okay, so this one only has 2 fireplaces. Okay, so this is the one that's worth the most, but I didn't ask that. I said how much the property that has the most number of fireplaces. Which one is that? That's this one, right?
See, I thought you was talking about the line going up. How many? That's why I didn't think it's 7.
Okay, so
7 is obvious.
Okay, so apparent,
What do you call that?
What do I call what?
Like in number 2.
Mm-hmm. This one? This value right here?
The variable that's going straight up. Is that a variable? Is that what that is?
No, the variable.
Or number 2.
The variable. Okay, let me answer your question. The variable is the number of fireplaces.
Right.
Okay? These are just values that the variable can take on. For example, a variable about you is something's coming in over there. What's your age? Okay? Everybody here has an age, and we might have multiple people the same age, whatever. That's just a value. Okay? It's not a variable, it's just a value. So all of these dots, these are all different homes that have 2 fireplaces. That's all that is. Okay? How many homes have 6 fireplaces? 1. How many homes have 5 fireplaces? 2, right? We've got this house with 5 fireplaces, but worth only maybe 170,000, and this place with 5 fireplaces worth, 360 or 370,000, something like that. Okay? There's only one place with 7 fireplaces. That's the one with the most number of fireplaces, and it's worth almost 400,000, 390 or something around there. Okay? So I think maybe some of you just read the question and take it at face value. You don't need to try to do any kind of interpretation beyond what the question is asking. It just says, what's the value of the property with the most number of fireplaces? Which property has the most number of fireplaces? We don't know the address, but we know it has 7 fireplaces, and based on the graph, we can get its value. Okay. Number 2, it says the following are a pair of scatter plots. The data are height and weight information from 200 individuals. In the plot on the left, the height is measured in inches, and the weight is pounds. In the plot on the right, the height is measured in centimeters, and the weight in kilograms. Yeah.
I couldn't, when I print, I couldn't get both of the graphs. I don't know what the problem was.
Okay. I don't know what's up. Okay. All right. So some people.
I have the same problem with the email, and he sent it directly, and I was able to print it.
So, I mean, you can also just click the picture. So most of these things you can just click the picture and you can print it out or something. Okay, so, everybody's computer is different, so I can't answer all of your tech support questions regarding printer issues you guys are encountering. I'm sorry about that, okay? But you should be able to view it and you should be able to answer your questions, okay? All right, let's go over this. All right, so the axes are labeled with values only. Use your knowledge of human height and weight to infer which variable is associated with which axis, okay? So here, one is measured in inches and one is pounds and centimeters and kilograms, so it doesn't say which one is height and which one is weight. So for this graph, which one is height and which one is weight? So, okay, so let's go through this. Okay, so for part A, the x-axis goes from 62 to 74. Is that going to be the height or the weight? That's going to be height, right? So x is going to be height, and y is going to be weight, okay? X, so the horizontal axis is x, okay? And vertical is going to be y, okay? Which axis has the height? Which axis has the weight? Oh, that was part A. Okay. Part B. In inches, approximately how tall is the tallest person? Okay. And approximately how many pounds does this person weigh? Okay. So the tallest person is this one right here. It's just under 74 inches, and he looks to be around 195, 190 something pounds, right? Maybe 193, just eyeballing. Okay, so 74 inches tall, weighs 193 pounds, okay? That's just a ballpark. If you say 195, 190, anything around there, that's fine.
Could you show me that again on the top?
Sure. Okay, so this is the plot. Who's the tallest person? It's this dot right here, right? Can we see that? We recognize that this is the tallest person. How much does this person weigh? Around 190, right? Between 180 and 200, a little bit closer to 200 than 180. I'm guessing 193, but whatever,
So you said the tallest person is that last dot over there?
Yes.
This dot, right? Because
I didn't have it either, so
Okay.
that's why mine didn't come off. When I printed the first time,
okay,
I printed
so
out.
maybe you have to look at your computer screen for some of these plots rather than printing them out. Okay. Okay, keep in mind the graphs plot the exact same set of 200 people. The data was just recorded in different units. The graph on the left has a correlation of 0.557. What is the correlation of the graph on the right? Is it going to be exactly 0.557, more than 0.557, or less than 0.557? It's going to be exactly the same, right? So the correlation is not affected by units. Okay, R is going to be exactly 0.557, exactly the same. Why is it exactly the same? Okay, what's the definition of correlation? Correlation tells us how strongly the relationship is, right, between the data points. And so we have the same set of data points for both the graph on the left and the graph on the right, okay? And so if the correlation over here, even though we measured in inches and pounds, it's the same data points, we've just converted them into centimeters and kilograms, they're going to have the same relationship, okay? So the correlation is positive. What does it mean to have a positive correlation in the context of this graph? All right, no, that's exactly what I said, right? So don't tell me the correlation positive means that we have a positive correlation. Okay, so large. Okay, so in the context of this graph, rather than just saying large value of x, it goes with large value of y. What do we say about? What can we say about people? There's a relationship between the height and the weight, and we want to say what? Tall people, yeah. So we're going to say people who are tall generally weigh more than people who are short. Okay. Or if you want to say large height goes with large weight, or high weight, I should say. And low height goes with low weight. Okay? That's essentially what we're saying. So, yes, there is positive correlation, but I don't want the answer to be there's positive correlation. I want you to say large height is associated with high weight, low height associated with low weight.
It's not enough if we say large value of x.
You know, because large value of x goes with large value of y can apply for anything, okay? I wanted it interpreted for this graph, okay? Because, you know, if you just learn this theoretical stuff, large x goes with large y, it's not going to be very useful, okay, in terms of just interpretations, right? It's much more meaningful. Okay, if somebody says, what's the relationship between x and y, it's not so useful to just say large x goes with large y. But if you can say, in general, taller people in general weigh more, and in general, shorter people weigh less, that's saying a lot more, okay? You can say, in general, people, can we just turn down the volume a little bit in the back? I think I'm getting some feedback here. Maybe we can say, you know, any x and any y variable that we have,
What's x and what's y?
you know, you should say what x and y are. Okay. All right, let's look at number 3. It says, think of the following pairs of variables. Imagine gathering the data and creating a scatter plot. What do you expect to see in the scatter plot? And for example, if we were looking at the weight of an apple in grams and its circumference in centimeters, in the scatter plot you would expect to see a positive, fairly strong linear relationships. I expect apples that have a large circumference to have a high weight. I expect apples with a small circumference to have low weight. I expect there will be a little bit of scatter, but the relationship to be fairly strong. Okay? So that's the type of answer I was looking for that. So let's look at 3A. Let's say we looked at the weight of an apple in grams and the weight of an apple in ounces. What would we expect to see there? Okay, so weight in grams versus weight in ounces. Okay, so we would see a positive relationship, positive, linear, very very strong relationship, right? Would we expect to see any scatter in the graph? So no scatter, right?
The same but different weight.
Yeah, we would expect to see exactly this, okay? If you know something's weight in grams, you know exactly what it will be in ounces, okay? If 2 apples weigh 150 grams, one apple is 150 grams and another apple is 150 grams, what is their weight in ounces going to be? Okay. Whatever it is, it's like 5 ounces or something, okay? If this is 5 ounces, then this one will be exactly 5 ounces, okay? There's going to be no scatter over here. Whereas, if you had an apple that was 150 grams and we measured its circumference, it could be, I don't know, let's say 25 centimeters here, okay? Apple number 2 could weigh 150 grams, and it won't necessarily be exactly 25 centimeters. Maybe it'll be 26 centimeters. It could be a slightly different sized apple that weighs also 150 grams. But if we're talking about weight in ounces and weight in grams, if you have 2 apples with the same weight over here, they're going to have the exact same value over here. Does that make sense? So there's going to be no scatter. Over here, a little scatter.
So the first one is weight in grams?
Yes. So it just says scatter means the dots aren't perfectly lined up, I guess. So I mean, for example, if we're talking about height and weight, there's scatter in that, right? I could take 2 people who are that have the same height. Will they weigh the exact same amount?
No.
Probably not, right? One person might weigh 200 pounds and the other person might weigh 150 pounds. So we've got scatter. Okay, if I take 10 people, all the same height, are all 10 people going to weigh the same amount? No. Okay. However, if I took 10 people and I measured their height in inches, I got 10 people who are 6 feet tall exactly, and then I said, oh, you know what, I want to convert this into centimeters. Okay, will all 10 people have the same height for centimeters? Yes. Okay, so if we convert from grams to ounces or inches to centimeters, there's not going to be any scatter, right? If we have 10 people who all are 6 feet tall, they're all going to be, 183 centimeters tall, okay? They're all going to have the same value for the other thing. So there's no scatter there. I'm sorry? So this shows no scatter. There's no scatter here, and there's a little bit of scatter here. Is that confusing or? Okay.
It is the same weight. If you have 5 ounces,
So
you can change it to.
So let's say this represents the apple that weighs 150 grams. Okay, and so on this graph it shows up as 5 ounces. Okay, let's say I pull up another apple, 150 grams. Will I put a dot anywhere else? No, it goes. I would have another dot stacked right on top of there. Okay, so for each value, there's no scatter. So I'm sorry, I'm at a loss for how to further simplify this. Huh? I did a conversion there. That's right. But I'm trying to just illustrate the idea of a little bit of scatter. We could have here if for one particular value, you can have multiple other values, there's going to be a little bit of scatter, right? So, I mean, okay. I don't know. Let's say I told you to buy 3 ounces of peanuts, okay? And you go to the store and you buy 3 ounces of peanuts. And then I say, how many peanuts did you buy? Just throw out a number. What do you think? Maybe it's 50 peanuts, okay? Now, if I told somebody else, go get 3 ounces of peanuts, and they measured exactly 3 ounces of peanuts, how many peanuts will they have purchased? Will they have exactly 50 peanuts? What do you think? It's the same weight, right? Okay. So I'm asking Raquel here. So I'm sending 2 people to the grocery store. Maybe I send 3 people to the grocery store, and I'll give them the same task. I want you to buy exactly 3 ounces of peanuts. Here's a scale, very accurate. I just want you to keep putting peanuts on until you get exactly 3 ounces, okay? You come back and you say, I got 50 peanuts, okay? Person 2 and person 3, what numbers are they going to come back with? Maybe it'll be different, right? Because peanuts aren't exactly the same size, right? One person can come back with 52 peanuts. Somebody else can come back with 48 or whatever, okay? So the fact that even though you all had the same task, getting 3 ounces of peanuts, the fact that you can come back with a different number of peanuts and not have broken my rules or anything like that means there's some scatter allowed in the number of peanuts, okay? And so that's what we have here, okay? I could say, go pick out an apple that weighs 150 grams, tell me its circumference. It's going to come back different, okay? Now, if I told you, go to the grocery store, buy 3 ounces of peanuts, how many grams of peanuts did you buy? Everyone's going to say, I bought 93 grams of peanuts, okay? Nobody's going to say, if somebody said, I got exactly 3 ounces of peanuts, no one's going to come back and say, I got 98 grams of peanuts, because that's no longer 3 ounces, okay? So that's why there's no scatter for this one, but there's a little bit of scatter in the other one, okay? All right. Okay, let's look at college students, okay? Let's say we asked a whole bunch of college students and we asked for their shoe size and their grade point average. What kind of relationship would we expect to see there? Okay, so we have shoe size versus GPA, okay? So we're going to see probably no relationship, right? Okay, lots of scatter, we would expect. So for this one, I would expect to see just dots all over the place. Okay, people with big feet, some of the people with big feet will have high GPAs, some of the people with big feet will have low GPAs. If we look at people with little feet, size 5 shoes, maybe they have high GPAs, maybe they have low GPAs. We're going to have everybody in between. So we're going to see no relationship between shoe size and GPA. Okay, is that all right with everyone? Okay, we're going to look at people of all ages and their grip strength. Okay, so what kind of relationship will we see? So what would we expect to see? We would expect to see, if we're looking at people of all ages, little kids, how strong are their grip? It's very weak, right? Okay, so as they get older, every year we expect the grip strength to get stronger and stronger until they reach adulthood, and we kind of expect it to remain around the same, right? So once you're grown up, yes. So okay, so this is what we're expecting, and then as you get older, we expect it to go down. So we expect to see some kind of relationship like this, right? Children have weak strength; they get stronger and stronger until they're grown-ups, and we don't expect it to fluctuate very much once you're an adult until you reach a certain age when your strength starts to decline again. Okay. So the answer there is we expect to see, in terms of the amount of scatter, we're going to see probably a decent amount of scatter, but then kind of also we'll see this general pattern of strength declining also, okay? Even Arnold Schwarzenegger is probably not as strong as he is today as he was 20 years ago, okay? So we won't, okay? So we're going to have what we call a non-linear relationship, right? Because it's linear means straight line. We don't have a straight line here, okay? That's what I was looking for, a non-linear relationship.
So saying that it's a positive and negative correlation with
You can say positive until, age 20 or something, and then negative after age.
That's one thing. I'm saying that it's both.
Okay, yeah, well, so to say positive and negative, you can't say that for a linear relationship, okay? You can say it's nonlinear, and you should break it up and say this part is going to be positive and this part's going to be negative, right? Because if I just told you, how much money does this person make? You can't say he makes a lot and a little, okay? You can say in the beginning of his career he made a little, later on in his career he made a lot, and then he messed up and now he makes a little again or something. You can say things like that. Yeah, if you explain it like that, but you have to break it up and say in the beginning there's a positive relationship, later on you expect, so I can kind of, so here we would have positive, and then here we would have no relationship, and here we would have a negative relationship, right? Okay, because if I took people between ages 25 and 40, we would not expect to see a relationship between grip strength and their age, generally, right? Because you can have strong people at age 40, you can have weak people at age 40. You can have strong people at age 25, weak people at age 25, okay? But if we looked at kids, ages 2 through 20, we would expect to see positive correlation between age and grip strength, right? We look at the 2-year-olds, they're going to be weaker than the 20-year-olds. And then if we go over a certain age, right? Let's say 60 to 90, we would expect the 60-year-olds to have more grip strength than the 90-year-olds, okay? In general. Yeah, you can say weak, okay? Yeah, there's definitely a negative relationship, but probably weak. Okay, so that's C. And the last one, okay. People, diastolic blood pressure and systolic blood pressure, okay? So, if you ever come across something you don't know, you might have to go to a dictionary or Google and say, what is this, okay? So diastolic blood pressure and systolic blood pressure, it's, whenever you go to the doctor and they tell you your blood pressure, they tell you two numbers, right? They don't just say your blood pressure is 120, they say 120 over 80 or something like that, okay? So what do we expect to see here? A positive relationship, right? So if your upper number is high, you're probably, the number on top is high, the number on the bottom is probably going to be high also, okay? If the number on top is low, the number on the bottom is low, okay? And in fact, the number on the bottom can never be bigger than the number on the top, okay? So we've got a positive relationship, okay? And I would expect it to be fairly strong, okay? So D is going to be positive, linear, strong. Okay, and number 4, pretty much all of your answers were on this slide. Okay, I just wanted you to kind of reiterate what I wrote here. Okay, so I'm not going to make a new slide. Huh? Yeah, just write. If you wrote the same things, that's fine. Okay, but as long as you understood what you were writing down, don't just blindly copy the words. Make sure it makes sense, right? So the only one where the interpretation of R equal to 0.816 makes sense is this first one right here. Okay, and the other ones there's all some kind of flaw. Okay, so over here we would expect a very high correlation with the exception of one point that sticks out. okay? And we should investigate why this one point sticks out. We shouldn't just say, oh, correlation's 0.816, that's good enough, okay? Anytime when you look at it, something in your brain should say, hey, what's going on here?
And when
Yes.
you're doing it, can you actually, because that one is throwing it up, you like take it out?
You could if there's a reason to take it out, okay? You should never throw away data points just because they're inconvenient,
Oh.
okay? Okay? Just because this one looks a little odd,
So,
you shouldn't throw it away,
so
okay?
what are you trying to investigate, just to see the reasoning?
Why?
You should look up, every data point corresponds to something or someone, right? So, if this is, somebody had to measure this, and somebody had to say, at 13, we had this value here. Okay, so somebody had to do that. And you should say, well, how did that happen? What's the story behind this? If it sticks out like a sore thumb like this, right? You should never just say, oh, well, that's weird, I'm going to throw this data point away. Okay, but you should do some investigation and ask some questions. And if you can't find satisfactory answers to the questions, you could do the data analysis without it, but you should note, I ignored this data point because it was strange and I couldn't find a reasonable explanation. But maybe there is a reasonable explanation, okay? Maybe this is the price of something, it's probably not going to look like this, but, let's say price of gas over the past something, okay? And maybe there was some kind of oil crisis that caused this sudden spike. Okay, if that's the case, leave it in there, right? That's a reasonable explanation. Okay, maybe this is somebody typing in numbers and they had a typo. Okay, in that case, throw it away, because if it's a typo, it's not a useful data point. Okay, that's why you got to investigate. You should never just throw away data points and say, oh, this is funny, let's ignore it. Okay, that's how people get marginalized and stuff like that. They just say, oh, you only make up 2% of the population, so we're going to completely ignore it, right? If that were the case, we wouldn't have services for people in need and special needs education and things like that. It could be, quote, convenient for policymakers to say, there's only just a few people, they're not important, we're going to ignore them, right? Ancient societies often did stuff like that. They would say, oh, well, this baby came out funny, so we're not going to support him. They'd throw him off a cliff or something, that's not today anymore, so you shouldn't just throw away data points, okay? They're not babies, but don't. Okay, so every data point represents something, okay? So this one is not a linear relationship, so it's not appropriate. And this one, you only gather data point for one x value, okay? So you're not going to be able to make any kind of meaningful relationship if you only have data points for 8s, okay, one x value and one value over here, okay? Okay, I hope you guys did okay on your homework. Okay, so I'll take a look. I'll check off your homeworks during the break. Make sure you guys do it. And again, we're gonna have a test next week. What is that? Is that a surprise? Huh?
I think it's the 15th.
I think I wrote in the calendar that we have week 4, exam 1, right? This is week 3, so yeah, week 4, exam 1. Okay, so that's gonna be your first thing. So anything I put in the homework is fair game for a test. Okay, it's gonna be closed notes. Homework 1 and 2.
Can I email you the homework, because I keep emailing you the homework, but I haven't received a return from you.
I'm sorry.
I email the homework to you every time, but I did not receive a return from the email.
I don't. You're not supposed to email the homeworks to me, but bring them to class. Okay. Okay. Well, I can try to look up what's going on here. So, yeah, turn your homework in class, right? So,
So, the homework one, two.
yeah, it's, I mean, yeah, okay. So I guess we can go over the homework first next week, and then you'll take the quiz after that. Okay, refresher week. Homework 1, 2, and 3. So I'm going to assign homework 3. I haven't finished writing it, but I'll have that written, and that will be covered on the test. Yes. So I've written the notes, and they're posted here from the lecture from last week, and I feel like this covers, and it's also on YouTube. You can watch. I feel like I covered it, but sure, I'll do that right here. Okay, so generally you have this. This is going to be positive. Okay, so overall trends. Negative, okay? Just, of course, it's not going to be exactly like this, okay? Dots with little scatter. This is going to be strong. More scatter. It's going to be weak, okay? So,
What does it look like if it was moderate? You should use the word
something in between. Something in between here, right? So strong to moderate.
It's almost the same thing, strong and moderate.
No, moderate is in between strong and weak, right? So, I mean, obviously, you know, we can imagine the amount of scatter going from little to more and more and more, okay? Okay. And no, it's
What kind of style? Multiple choice or just a similar like homework?
probably multiple choice, okay?
Multiple choice?
Yeah, I'm still working on it, okay? So here we go. All right, is that okay? I'm going to